It has always been said that the aircraft fly because of the shape of their wings. But do you know how that actually works? Today I'm bringing to you the ultimate video about how an aircraft really flies. And if you stick around until the end, I will share a fun fact that it might blow your mind. Bernoulli's equation describes the relationship between speed, density, and pressure within a fluid. At the speeds that commercial planes fly, we can treat the air as incompressible. So the equation basically tells us that total pressure, which is the dynamic pressure plus the static pressure, must be constant at all times. When the air speeds up, dynamic pressure increases, so the static pressure must decrease. That's what happens on top of the wing. The air that goes through the upper side moves faster than the air that goes below it, thus creating a lower static pressure on the top side. As the fluids move from more pressure to less pressure, we have some force basically sucking the plane into the air. But there's another thing happening. That's the Coanda effect. When a fluid comes close to the surface, a small low pressure area is created which bends the fluid and attaches it to the surface of the object. This might sound super strange, but it's super easy to check if you have streaming water and a spoon. If we combine this with Newton's third law, which states that every force has an equal and opposite reaction, the result is that the air that's being pushed downward along the wing creates an opposite force upwards. The combination of all these effects is what we call lift. Did you know that if we get a section of a propeller, it's exactly with the same shape as a wing? They use the same method to create a force to move us forward, or in the case of helicopters, to move it upwards. And now, what I promise. Did you know that pitot tubes, the one that gives us indication on the aircraft speed, work using Bernoulli's theorem? Can you guess how? I'll read you in the comments. Bye!